Hey there, universe nerds! Let's rewind the cosmic clock all the way back to the beginning, the very first moments of the universe. The Big Bang wasn't an explosion in space, it was the expansion of space itself. But what happened in those first seconds? How did nothing become everything? Today, we're breaking down the earliest chapters of the cosmos, from fractions of a second after the Big Bang to the birth of the first atoms. The story begins at time zero. We don't know exactly what triggered the Big Bang, but what we do know is that about 13.8 billion years ago, the universe began expanding from an extremely hot, dense state. At less than a trillionth of a second, temperatures were trillions of degrees, and the entire universe was smaller than an atom. Space, time, matter, and energy as we know them all burst into being. Physics as we understand it breaks down at this point. Quantum gravity would be needed to fully explain it. Between 10 to the minus 36th and 10 to the minus 32nd after the Big Bang, something extraordinary happened: cosmic inflation. In this tiny fraction of a second, the universe expanded faster than the speed of light, growing from subatomic size to something macroscopic. Inflation explains why the universe looks so uniform today, why the cosmic microwave background is nearly the same temperature everywhere, and why galaxies formed the way they did. Without inflation, the cosmos wouldn't look like the one we see through our telescopes. By the time the universe was a fraction of a second old, it was a soup of fundamental particles: quarks, electrons, neutrinos, and photons. Quarks combined into protons and neutrons, the building blocks of atomic nuclei. This was the quark-gluon stage, a dense, hot plasma where particles collided constantly, forming and annihilating in a violent dance. Modern particle accelerators like the Large Hadron Collider tried to recreate these conditions to understand the universe's earliest seconds. After about 1 second, the universe cooled enough for protons and neutrons to start sticking together through nuclear fusion. In the next 3 minutes, the first atomic nuclei formed in a process called Big Bang nucleosynthesis. Hydrogen, helium, and a trace of lithium were created, the basic ingredients for all future stars. Almost everything heavier, carbon, oxygen, iron, would only come later inside stars and supernovae. But in those first minutes, the lightest elements that still make up most of the universe today were born. For the next 380,000 years, the universe remained a hot plasma, with electrons freely scattering light. It was opaque. No photons could travel far before bouncing off particles. Then came recombination. As the universe cooled to about 3000 K, electrons combined with nuclei to form neutral atoms. Suddenly, light could travel freely, filling the cosmos with the cosmic microwave background radiation, the faint glow we can still detect today, a baby picture of the universe. From there, gravity took over. Tiny fluctuations in the density of matter, seeded by quantum fluctuations during inflation, began to grow. Over millions of years, matter clumped into the first stars and galaxies. The first stars were huge, short-lived giants that forged heavy elements, exploded, and spread the building blocks of planets and life. From a smooth, hot plasma, the universe evolved into a cosmic web of galaxies and clusters we see today. What's most incredible is that we can study all this with real evidence. Particle physics experiments recreate early universe conditions. Observations of the cosmic microwave background confirm inflation and nucleosynthesis. Telescopes like the James Webb Space Telescope look back in time to the first galaxies. The fact that we can reconstruct events from 13.8
billion years ago is one of humanity's greatest scientific achievements. So, what really happened after the Big Bang? In less than a second, space expanded unimaginably fast. In minutes, the first elements formed. In hundreds of thousands of years, light was released. And in billions of years, stars, galaxies, and planets appeared. The universe's origin story isn't just theory, it's written across the sky, waiting for us to read it. And the more we study, the closer we get to understanding how nothing became everything.